Hello, dear audio wizards and fellow music makers. This is the 10th and last episode of this compression Bible. In the previous episode, we talked about how to make glue, and we also put a bunch of different plugins under the microscope of Plugin Doctor in order to understand how those plugins were reacting and showing you what you can read out of something like Plugin Doctor about the knees, about the attack times, about the harmonic distortion, about the tonal curve, etc., etc. For this last episode, we're going to dive in the last bits we didn't talk about yet, which is the difference between broadband and multiband compression, the difference between multiband compression and dynamic EQ, and most of all, how to set your compressor to avoid any additional or any unwanted harmonic distortion. Multiband versus broadband, when to use which one. I would say, like most of the time, for individual tracks, broadband is what you are after. If you want to control the feeling of the dynamic of a sound, if you want to imprint some movement, or if you want to add some groove with group compression to glue things together, most of the time what you want is broadband compression, because you want the whole frequency spectrum to be reacting, to be pushed backwards and coming forward, to move. And so you want all the frequency bands to work together, to work as a whole. But sometimes you want or you need multiband compression. Multiband compression, on the contrary, is more used when some parts of the spectrum are out of control. It's not printing some movement to the sound, it's making something more transparent, but it's controlling some frequency ranges. Or in the case of mastering, for example, if you want to add punch to the low end because the low end is too loud, but if you dip it just with an EQ, with an EQ shelf, you dip the low end, then it's at some point it's getting at the back. It's not punchy enough. So in this kind of case, then you would dial in a multiband compressor, and on the lower band, leave some attack time open and push the low end downwards when the kick is playing. So you have the initial transient, the initial attack, and then the decay of the kick will be brought down. So in this case you can create a kind of punch to the low end while not making the whole mix pump or react too much. It can be, on the contrary, some for de-essing. If the S's, the sibilants of a track, are too prominent, then you can choose to just select that range from 4, 5 kilohertz, 6 kilohertz to 8, 9, maybe 10, depending on the take. Usually it's the 6, 8 kilohertz mid-center part that you want to tame with the S's. And so you can just tame the S's, not tame the whole vocal. You don't want a vocal take to be pumping on everything if it's just the S's that are making the problem. You just want the compressor to react on that range, and also just to tame that range. Maybe you don't want the whole vocal to be ducked, you want the low end presence to still be there, for example. So there is no hard rule here, but it's more a question of intention. Do you feel that it's the whole sound that needs to be moving, that needs to be working with the beat, that needs to be tamed, that is too loud, that is too dynamic, then it's broadband. If you feel that there are just some frequency ranges that needs to be addressed, then it's a multiband compressor. The difference between a multiband compressor and some dynamic EQs is the range, the width. Multiband EQ is going to be used when it's a pretty big chunk of frequency range you want to address. As I said, with a beat, with the whole low end area of the kick that needs to be pumping. Your kick most of the time has a pitch envelope, so it's not a fixed frequency, and you might want to control that whole range of low end frequency during the pitch drop, the ooh, till the low part. While, for example, with resonant frequencies in a vocal or a piano or whatever, then there are just some frequencies due to the distance from the microphone, the shape of the instrument, and those are always the same frequency. They are in one position and you want to tame these. And so for these kind of processes, you want to use a dynamic EQ. Dynamic EQ will be more for surgical things, while multiband compressor will more be for frequency ranges. The last thing is that except from Kirchhoff EQ, most of dynamic EQs don't have such in detail control of the attack and the release of the compressor of the dynamic EQ. So if you really need advanced control on that, either to push the transients up or to squeeze the transients or to let them through and have a pumping effect, then maybe at some point you will need a multiband compressor instead of the EQ. But most of the time you can find something working while pushing or ducking, and maybe ducking the dynamic EQ while pushing the whole frequency range above, or the opposite, making the whole frequency range a bit quieter and pushing the EQ upwards this time. So fiddle around, play with it, but you get the whole idea. Dynamic control over a wide range, multiband compressor. Dynamic control over some specific frequency, dynamic EQ. Okay, so let me try to untangle this last bit. When would you need a compressor? When do you need a limiter? And when do you need a clipper? And what are the differences? Those three tools actually offer a control over the loudness of a signal. And if you look at the downwards compression, they all work in the same way, that they actually are shaving off the top end. There is no upward clipper because clipping is working with the ceiling. So the first thing is, most of the time, compressors have slower attack times, except for the FET compressors. They have slower attack times than the limiters. So if it is about really shaving off the transients and shaving them off in a clean way, because FET compressors shave off, but they add a lot of distortion. So if you want to shave the peaky transients in a clean way, what you want to use is a limiter, not a compressor. So first things first, taking control over the short transients. Remember, like 10 to 40 milliseconds, or sometimes even less than 10 milliseconds transients is controlled with a limiter, not with a compressor. You can get it with some color, but if you want to make it transparent, like on mastering kind of approach, then you want to do this with a limiter. Now, that's the difference. Limiters have a shorter attack time, but they still have an attack time. They still have a release time, like the compressors. You need to go above a certain threshold, then the limiter starts to react with infinite ratio. You can see actually a limiter like a compressor with a very, very, very short attack time, infinite ratio. There is nothing peaking above that threshold, and with a medium release time. Okay, compressors have slower attack times and their ratio doesn't go that high. Limiters have faster attack times and an infinite ratio. Okay, now what's the difference between a limiter and a clipper? The clipper has no attack time whatsoever and no release time whatsoever. It's instantaneous. It's just working with the signal, and as soon as the signal gets above the set threshold, the set ceiling, it's just shaving it off. But what does this mean? If you transform a sine wave into a square wave by shaving it off, you are creating harmonics, you are creating distortion. So the difference between limiters and clippers is that clippers induce a lot more distortion. They work very well on very fast content, but they add distortion. So if the only thing you are controlling with the clipper are the few milliseconds of transients, you're good to go, because most of the time those transients are high frequency content that is also not correlated, that is also not in a harmonic scaling, it's noise. So removing some of the transients to replace them with a few milliseconds of noise makes barely no audible difference. But when it comes to sustained sound, to low end content, clippers add distortion and it's making the whole track fall apart, while limiters allow you to control the low end on a more sustained period of time without too much audible distortion. Okay, so for transient control, limiters or clippers, depending on how loud are the transients and how long they are, you get it, right? And so this is why most of the time you are good with a combo of clipper and limiter. Controlling the microdynamics on the individual tracks, and if there are some peaks that are really poking above, then you might use a limiter or a clipper. If your limiter is too slow, if the transients are very super snappy, use a clipper, and then group the tracks together, use group compression, and now you get the full range of dynamic control from the microscopic transients, very sharp, to a bit longer transients, to some low frequency content, and to some longer elements, to some groove and pumping that the compressor is leading. So you can see it going from the clipper to the limiter to the compressor, depending on the frequency content and on the length of the reaction you want. A limiter or a clipper will barely not induce any movement. If you push a limiter too far, then it will be a bit pumping, and so it can print some movement, but it's only on the release phase. It's barely the attack phase that you will hear. And because of this working together of clippers and limiters, this is the reason why, for example, FabFilter Pro L2 limiter has a first stage of clipper, of transient control, and then a stage of limiter. It's cascading in order to get full control. Limit 1 from Leapwing Audio does exactly the same the other way around. It's first the limiter and then the clipper, but you get the point. Those high-end limiters encompass both features, because in order to work properly and to really shave off the transient while getting a proper control over the tone, you need the clipper part and the limiter part. I hope you like this content so far, and be sure to like the video to show me some support. If you don't want to miss any other bits of no-nonsense content, be sure also to subscribe to the channel to be notified for any upcoming video. How to avoid distortion, and more precisely, how to set up your compressor to avoid distortion depending on the lowest frequency in your track. The faster the release and the faster the attack will be, the faster the compression is going to kick in. And if it kicks in too fast, you will square off your sine wave. And if you square off a sine wave, you are creating a square wave, and a square wave means more harmonics, so more distortion. So obviously there is a link between attack time, release time on a compressor to avoid creating harmonics on a certain lowest frequency present in the track. That's a truth on the principle. I discovered weird behaviors, and spoiler alert, in fact, there isn't a proper formula for all compressors. Let's dive into the juicy things. For this test, I put on our dear plugin doctor, and what I did here was to dial in some low frequency content. It's a sine wave playing at 48 Hz. It's the closest I could get in the plugin doctor from 50 Hz, and it's playing at minus 0.2 decibels, so it's close to 0 dB full scale. With this starting point, I put on Kotelnikov from TDR, and what I did here is to dial in some threshold, having a hardening and having it reacting on the peaks, because I want the fastest possible reaction in order to understand what's happening. Okay, so if you have a certain frequency, let's say here 50 Hz, the period of that frequency is actually 20, because you have 20 times 50 Hz in 1 second. 1 second is 1000 milliseconds. If you divide 1000 by 50, you get 20, right? Okay, so the attack time and the release time should be of 5 times the period to avoid any excessive artifacts and any excessive total harmonic distortion. So in this case, I have Kotelnikov, and we're going to look at this. We see obviously if I have no ratio and the threshold is super high, there is no harmonics happening. I dial in full ratio, I bring down the threshold to get some reduction happening, let's say like minus 20, whatever. Of course, when I'm increasing the attack time, I realize there is some diminution some rolling off of the harmonics. So let's dial in 100 milliseconds, and on the release as well, we can even go a bit above. And on the release here, as you see, we have a pretty strong decrease, but there are still harmonics generated. The fundamental is peaking at -14 here, post compression, and we have the first harmonic at -60, so we are 46 decibels below. It's very quiet, but it's still audible. Usually we consider like -60 decibels as a minimum to say something is inaudible. Okay, so that's the first thing we see here. Then I tried things out with different attack times and release times on different compressors because I was hoping to come with a proper answer. The thing is, I didn't. Let's dial in some things. So the first thing I tried is obviously Pro C2 from FabFilter. I'm gonna go for the classic one to compare more or less apples with apples, right? And if I'm looking here at the harmonics, what I'll see is that even if I dial in 100 and 100, we have still a pretty strong total harmonic distortion present. But weirdly enough, my finding with Pro C2 was that the look ahead has more impact than anything else here. Let's have a look. I'm going to turn on attack at 0, release at 0, turn on the look ahead, and you will see. Wait a second, it's coming down, down, down until it totally disappears here. And so we have here 50 Hertz frequency being played, which means that the period is actually about 20, and the minimum look ahead is at 10. It's half the period. So if we divide the period by 2, we get no distortion at all with Pro C2, even with the fastest attack and the fastest release. If I would dial in a higher frequency, twice higher, let's say, okay, I'm going to go for 100 Hertz. 100 Hertz means that actually the period is 10 milliseconds, so I'll go for half of that, I'll go for 5, and you see with 5 I have still a very clean signal. If I would draw below that, look, out of sudden all the harmonics appear. But if I'm here and I start to playing around with the attack time, look at this, it still is pretty strong, even if I dial in release. So on Pro C2, of course, attack and release have an impact on the total harmonic distortion, yet what has the most impact is not the attack or the release of the compressor, it is the look ahead. Let's dial in another compressor we all very well known, and it's the isotope ozone dynamics. For this one, it's going to be a bit more tricky because I first have to bypass totally the limiter. And let's dial in a similar setting as we did earlier. Let's dial in -20 and let's see what's happening here. No softney, hardney. I want some hardney. Let's look at this. Attack and release have kind of same impact. I can say that I did some tests like having attack, for example, at 100 milliseconds and the release at 20, and then shifting the opposite, so like this, and then now going for attack at 20 and release at 100. It's kind of similar. The only thing, the global decay of the harmonics is more or less the same. It's very similar. The only thing that I realize is that if the release is bigger than the attack time, we create some dips in the curve, like we had here, some dips, so the total harmonic distortion is lower. But to get a very, very clean compression without harmonic distortion with the dynamic from isotope, the attack time should be around 3 times the period and the release around 4 times the period. So let's apply this formula. The attack time is 3 times the period, so I should go for 30. Let me dial in 30 here. and the release 4 times the period, 40. And with this, look, we have something that is very better. We are more than 60 dB below. This is already a very clean compression. Let's dial in another one. Let's dial in here the threshold, do the same as the other ones, -20. Here we go. Let's dial in a very strong ratio like 100, limiter type of ratio. And with compression, it's the opposite. On the other ones, we saw actually that the release had more impact. On compression, it's the opposite. The attack has more impact. And the rule I came for this one is attack more or less 4 times the period and release 2 times the period. So again, we are at 100 Hertz here, so it's 10 for the period. Let's dial in the attack 4 times. Let's go for 40 and release 2 times the period, 20 milliseconds, which is actually very fast. And look, we have already a very decent decaying without any look ahead. Where I want to go here with all these explanations is there is, of course, a link between attack time, release time, and total harmonic distortion, but every compressor has another different behavior. I also tried the M comp, and the threshold at which I was compressing had a strong impact on the total harmonic distortion. So it looks like the reality is more complex than what it seems, yet attack times, release times have a tremendous impact on the total harmonic distortion. And so, long story short, I can only recommend you to try out your favorite compressors to see how they react and to understand the link there is between the lowest frequency you're going to be playing in a track and the settings you need to dial in your compressor to be totally transparent. This being said, sometimes the settings are not working because there's not only the total harmonic distortion, there's also the groove the compressor is printing to your whole track. We are talking here about mastering type of uses, and you want the compressor to be working musically, to be adding the vibe and the color you want. So there is a trade-off between, I don't know, maybe the punch, the sharpness of the compressor and the total harmonic distortion. As always, there is no one setting for everything, but at least now you have some ideas of what to look for in your compressor, and so you know also how to read and how to check your own tools in order to achieve the desired results.
Hello everyone, I hope you are doing fine, and today we're going to talk about the big debate that is online about should you compress before or after EQ, or should you put your EQ before or after the compressor. Let me first ask you a question. Do you want your compressor to be reacting to some frequencies that will be removed, that will not be heard anymore? So, long story short, if you roll off the lows, if you make big cuts to remove resonance frequencies and some sound, if you are basically doing any EQ move to clean out your signal, this is something you want to do before the compression, because you don't want the compressor to be reacting on all that dirt, on all that trash you are taking out. If you want to bring some colors, this is another story. If you want to shape things to bring some tone, you might do it before, because then the compressor is going to be reacting to that tone and shaping, even adding color to that. Or if you want to compensate for the tone the compressor brought, you might actually EQ after the compressor as well to shape a bit more the tone. But long story short, everything that is about cleaning the sound before the compressor, and that's it.
This wraps up this whole compression Bible. I hope through all these videos you learn quite a few things about compressors, that you now feel comfortable and fully in control of this tool. I hope it was helpful and that it will bring your music to new heights. Stay tuned for more. Feel free to share this content if you feel that it could help someone else, and don't forget to hit the little like and the subscribe buttons below. Thank you for everything, and see you soon in some other videos. Take care, bye bye.